All right, number 57 on page 851. Just talking about comets. Some comets, such as Halley's Comet, are a permanent part of the solar system, traveling in elliptical orbits around the sun. Other comets pass through the solar system only once, following a hyperbolic path. To be honest, I kind of thought that if something had a hyperbolic path, that it wasn't called a comet. I thought a comet, by definition, was something that was in elliptical orbit, but apparently comets, I guess, are just rocks flying through the space, right? Maybe. The figure below shows the path of such a comet. Find an equation for the path, assuming the closest the comet comes to the sun is that many miles. Okay. And that the path the comet was taking before near the solar system is at a right angle to the path it continues after leaving. Okay, well, there we go. So basically this picture, right? We are going to put, the origin is already defined for us, so that's right. Okay, so the center of this hyperbola is at 0, 0. And then, now we don't know the A value, nor do we know the C value. The sun is at one focus, and then, that the vertex is right there. But I do know that C minus A is equal to 2 times 10 to the 9th power. Okay, so the equation, since it's centered at the origin, the hyperbola is going to have the equation. It's a sideways hyperbola, so x squared over something minus y squared over something equals 1. I just need to find the two somethings. A is a horizontal distance to the vertex, so that's going to be 2 times 10 to the 9th power squared. That's going to be your A value squared. I'm sorry, that's not the A value. We don't know the A value or the B value. This is the difference between them. Okay. So how are we going to figure out A squared and B squared? So I have one equation for A and C. I also know C squared equals A squared plus B squared. So that's another equation, but I introduced another variable. Oh, you know what? I'm sorry. I was stumping myself on this one. The other key point that we need to know here is that this is a perpendicular axis. That means that if I were to draw the central box, the B value and the A value are actually the same. Oof, sorry. I give you guys a problem that I can't figure out myself. So that's a key point that tells us that A and B are the same. So if A and B are the same, then this equation simplifies to C squared equals A squared plus A squared, or 2A squared. There we go. And now I have two equations. Whoa. Not my day. Two equations with two unknowns. So we should be able to find A and C. And if we have A, then we also have B. Okay, so I guess I'll just solve this for C. C is equal to A plus 2 times 10 to the 9th power. Then plug that C into here. A plus 2 times 10 to the 9th power squared equals 2A squared. Plug it into that one. So this is one equation with A squared. Now, unfortunately, to solve this by hand, I'd have to FOIL this out. A squared plus, 2 times 10 to the 9th times A plus that thing squared. It would give me a quadratic equation in terms of A that's kind of ugly because it's got that huge number in it. So I'm going to pause the video and I'm going to put this in the calculator to solve it. So just hold on. So again, I'm just going to use my calculator because I don't want to do the work here. Notice though, whenever I put it in the calculator, I said solve. I'm going to solve this equation for A. When I put in the scientific notation, you can actually hit the 2 and then hit this little the E button to get scientific notation. It's kind of a nice shortcut, but so that equals that. So I get a negative value or a positive value. I want the positive value. So I'm going to take this guy. So that's my A value. It's also my b value. And then I need to square it to get a squared and b squared. So 233 to the 19th. So my final equation is x squared over 2.33 times 10 to the 19th minus 233 times 2.33 times 10 to the 19th power equals 1. This is not, the type of thing I'd put on the test, but yeah, that's it.